Very quiet ride. There's that demonstrator answer. Look for, see if you can see the...
I do want to readdress a couple of things I said this morning. I had talked about our ISDC staff. Josh came into the room as I was making the comments, so we gave him a round of applause. But now Deb Cohen. Deb, can you stand up, please? And Angela Pura. We didn't get an opportunity to recognize you guys this morning. And my comments of this morning really stand. I mean, they have done a Herculean task in getting this conference put together in a very, very short period of time. So give them a pat on the back if you see them walking around. So again, there's tickets available for tonight for the gala. It's going to be some really fantastic programming, and we'd like you to join us if you haven't already signed up for it. And just a little bit more of administrivia. We're still working the registration and meal tickets. I believe that we'll be able to get that all squared away by early this afternoon. Do we have an update from SpaceX yet? We're still really close. We're that close? Okay. Well, we're just about there, so we'll keep you posted on all of that. So this afternoon is we have a great opportunity here to welcome Eric to the stage. First and foremost, Eric is a good friend. We've worked together off and on over the last few years. He has got an incredible background, an incredible story. You know, I think that when we look back at this time, sort of as we look back at any new industry coming on, there's always that group of individuals that you identify with being at the forefront. I really call them sort of the titans of these industries. You know, and folks who are ubiquitous and very well recognized with these types of things. And Eric is certainly up there with a handful of others. Eric has a long track record of successes, having started Space Adventures in 1998. They have brokered 8 private flights to the International Space Station with 7 astronauts. And the reason that those numbers don't match up is because one gentleman liked it so much that he wanted to go back. And I understand that they're still in the process of doing that, but they're also looking further forward to a greater mission, and that is doing a circumlunar flyby using a modified Soyuz vehicle. And I remember when Eric made this talk a couple of years ago, and you could kind of see people squirm in their seats, and he goes, no, I know that there are people interested because we're talking to them right now. And that's a pretty high dollar figure, and since that time, I understand you've sold 1 seat, and there's 1 more to go. So, you know, if you have the means, then I'm sure that Eric would want to talk to you afterwards. So Space Adventures is just one of his successes. He is the chairman of the Commercial Spaceflight Federation. He's also the CEO of Intentional Software, working for Charles Simonyi from Microsoft, doing some really radical things with new types of software. But for today, he's going to be talking about his latest venture, that is Planetary Resources, which I'm sure you've all heard about in the news recently. They are going to go to an asteroid, or many asteroids. And they're not only going to explore them, they're going to execute what's the second half of the NSS vision, and that's utilizing the resources of space for the betterment of humanity. So this is a real privilege to welcome Eric here today, and this is his first talk since Planetary Resources announced its intentions several weeks ago. So this is a real honor for us to welcome him, and please join me in doing so right now. Eric?
Well, that's very kind of you, Paul. Thank you for the introduction. I really do want to shout out to Elon and SpaceX one more time, because Stephanie, can I embarrass you for one moment? I mean, I think just as an industry, and you know, we'll look back on the day that the first spacecraft, privately built spacecraft, docked with ISS as the beginning of a new era in commercial space travel. So congratulations again. It's a big day. And it is companies like SpaceX and others that are going to help enable companies and efforts and entrepreneurial projects to get literally off the ground into space and try to envision that dream, to make Star Trek real, to make the second half of the NSS goal real, which is really settling the solar system. And so that's what Planetary Resources is about. So this is going to be a fun chat. I have maybe 25 slides. I'll try to go through them not too fast, but to leave enough time for questions. I will also invite my good friend of 20 years and business partner, Chris Lewicki. Chris, you can stand up. Chris is the president and chief engineer for Planetary Resources, and during the Q&A, Chris and I will probably answer those questions together, so you guys can have some fun asking questions of him as well. So anyway, let's get started. Planetary Resources is about asteroid mining. And how it really got started, so my other co-founder in this company is a gentleman that many of you, probably most of you know, Peter Diamandis, the founder of the X Prize and CEO of the X Prize Foundation. And Peter also was a co-founder of Space Adventures, which many of you know my background from as well. And Space Adventures, of course, started to prove the marketplace for space tourism and private space flight, and is still doing so today. And you know, the tourism market is a great market, and something certainly that's worth billions and billions of dollars in the future. And as the cost comes down, will enable even more growth. But it's dwarfed by the market in the world for energy and resources. And as Peter and I were thinking a couple years ago about what is that next big step in commercial space, what is that future that we read about in Heinlein's books and literally the future of Star Trek and those sorts of things, what is it? And it really is about opening up the resources of space and bringing the resources of space into our economic sphere of influence. And so we really thought about that, and we came to the conclusion, so the company is really about more than just asteroids in particular. It's about a broader vision of making the resources of space accessible for space exploration, but also even for bringing back to the Earth to enable prosperity and growth decades into the future as our planet, which is set with a fixed amount of resources, grows and people start to become a bigger and bigger drain on those resources. And so that's our mission and vision, is not only to bring those resources of space into our economic sphere of influence, but to lead the way and to really create an industry behind this. I mean, we would love to see as many competitors, as many industry partners and players out there as possible. It's our goal to really bring the energy and mining industries into this game. One of the nice things about resources as an industry is that they're actually used to dealing with projects on long timescales. So when a new resource find is decided to be pursued commercially, or they're going to dig a big hole and all the way down through the bottom of the North Sea and build a platform there and things like that, those things take 20 or 30 years, and they plan for that financially. And so that's attractive because large amounts of money can move into these projects through known mechanisms, and it can do so in the same way as it happens on Earth. So, okay, let's talk about the asteroids. People have talked about resources in space from many sources. There's lots of good places. I mean, the sun, of course, is a resource, and we use the sun's energy every day. That's the biggest resource we get from space right now here on Earth. The moon is filled with resources. But we chose the asteroids because, in our view, they are the low-hanging fruit of the solar system. They are not in an appreciable gravity well. They are accessible. And not only are they accessible, but they have a lot of really interesting materials and elements on them. And so many of those, as you really get in and study the science of asteroids and their origins going way back to the very beginning of the solar system, you learn that the resources that we need as humanity to explore space are within those asteroids. You know, as I look back and imagine the future history of the Earth, there's a few really nice things that sort of nature gave us as a gift. It's really nice that we have the Earth's makeup as it has liquid water and air and all these kinds of things that are so supportive of life. And it's really nice as a humanity that we have fossil fuels that have driven our growth for the last few hundred years. And I think when we look back millennia from now, we'll be very appreciative for the fact that we had near-Earth asteroids, because I think that the materials and the resources and the energy effectively contained in the near-Earth asteroids is an essential element of getting millions of people off the planet, millions of people into settlements off the planet, whether it's in Mars or the moons of Jupiter or wherever. And so the near-Earth asteroids are great. So we built up the company, and I'll talk a little bit more about some of our backers and some of the folks we have working with us. But you probably, most of all of you heard about the company at our launch event, or a couple days before the launch event. We had a little bit of a interest, shall we say, leaking prior to the actual press conference. But it was a huge press conference. I mean, we were all over the place. And my favorite part was that I woke up 2 days after, and I made it till about lunchtime before someone said, "Hey, that was really fun on the Daily Show last night." And I was like, "What? What are you talking about?" And I had no idea that we had been made fun of by Jon Stewart on the Daily Show, and I was quite proud of that. So it's a nice little checkbox to have been made fun of by Jon Stewart. So I think we have that clip here coming up. So in terms of igniting the passion of the industry and even people far beyond our space advocacy industry, we really hit the ball out of the park. Very humbly speaking, it was just an unbelievable response. When we say, for example, job applications, I mean, these are not people who sent their resume by email. These are people who went to our website and filled out a questionnaire that was detailed and frankly borders on offensive, and is very, you have to be passionate to fill that thing out. And within just days, there were a couple thousand of these people who want to come and work with us. And similarly, for people who are, it's funny, as a space entrepreneur, the earliest days of space adventures were, of course, to meet somebody who wants to invest in your company is like the holy grail of your year. And we had people sending emails saying, "Just send us your bank information, wire transfers on the way." They want to invest so badly. It's just amazing. And so that gave me a lot of hope and perspective. And I think just as to take a big view for a second, this is really a time where all the pieces are starting to come together. You have the space transportation piece with SpaceX and Sierra Nevada and Boeing. We have the NASA piece where the government is really doing interesting things and looking to work with the private sector. And we have the scientific piece, and we have the international piece that's coming together with other countries similarly doing these things. And now hopefully we'll start to fill in the resource piece, and then the entertainment and all these things. So the space future that we all dream of, I can see it formulating in my mind's eye, just as many of us can. And I think the next 10 and 20 years are going to be really exciting for those of us who've been waiting for this for a long time. So here are just some fun quotes. We put together probably, 3,000 or 4,000 quotes. These are quotes lifted from comments on news articles or blog entries or whatever. And there's a couple that I just want to read out loud because I liked it so much. The one on the bottom right: "I love you all so much. Thank you for inspiring me to go back to school. Malcolm L." So this was a big thing. A lot of students getting excited about the future, and reminds me of what it must have been like with the early days in Apollo, where the young generation, and we're seeing that again now with companies like SpaceX and a lot of the new space companies that have the new generation getting interested in space. And so that was really inspiring. And then the one in the middle there, it says, "I am tearfully joyous that this company now exists. I felt that a resource-strapped humanity will always look inward and drive global conflict. Thanks to you, humanity has an outward-looking hope." And while that's a bit grandiose, it's true. Resource scarcity does drive conflict. And the ability to see things in a world where we can add to the pie, and it's not a zero-sum game where one country gains at another's expense, that's really inspiring, and that gives us a lot of hope for the future. Frontier I remember, I don't know if Bob Zubrin's here, but 15 years ago when Bob was first talking about Mars Direct and the idea of exploring Mars, he made great points about how our human values are much more cultivated and grown in a frontier society where freedoms and all these things are necessary and promoted conditions when you have a world where you're out there exploring. And so clearly I'm speaking to the choir here, but that was really inspiring for us.
This may seem like science fiction, but today a group of space pioneers announced plans to mine asteroids for precious minerals.
Space pioneers going to mine asteroids for precious materials. Boom, boom. Yes, Stu Beat is all in. Do you know how rarely the news in 2012 looks and sounds how you thought news would look and sound in 2012?
Love that. There's more.
I love this story, but it seems... I love this story. But let's face facts, it seems a little far-fetched. That's why it's a perfect candidate for our brand new segment, Bull or No Bull, with astrophysicist Neil deGrasse Tyson. Let's put 60 seconds up on the clock. Good evening, John. Dr. Tyson. Good evening. Dr. Tyson, tonight's question. Yeah. Asteroid mining. Bull or no bull?
John, in this case, the answer is no bull.
Amazing.
And John, your opening credits still show the Earth rotating the wrong direction. I'm just saying.
You gotta love that. That was so fun. I watched that 20 times since that came out. All right, so let's talk about asteroids. Asteroids exist in the solar system in practically limitless numbers. Obviously, for those of you who are well educated in space science, you know that the main belt has literally hundreds of millions of asteroids. I mean, the main belt is, the riches in the main belt are truly untold. But we're not talking about the main belt at Planetary Resources. We are focused on the near-Earth asteroids. And what still boggles the mind is that we have only yet discovered about 10,000 near-Earth asteroids out of, depending on where you draw the dividing line for what's an asteroid and what's still just a tiny little rock in space, somewhere between 500,000 and 1 million. So we've discovered somewhere between 1% and 2% of the near-Earth asteroids. That's amazing. There is so much out there yet to be discovered, and yet of those 10,000, we have at our disposal, if you will, more than enough resources, more than enough water, ice, more than enough precious metals, more than enough materials to really grow a spacefaring society. And these resources are not difficult to reach. There are about 17% of those near-Earth asteroids. They're in fact easier to reach than the surface of the moon. So they're very much in the Earth-Moon class of system. They're close by. Even though they may be separated by us from anywhere from a few lunar radii out to tens of millions of miles, they are definitely energetically in the neighborhood of the Earth, and they're very, very, very accessible for humanity. And so that's why we chose the asteroids. Again, I like to call them the low-hanging fruit of the solar system, or the stepping stones to the rest of the solar system. And it's still, we'll come to a slide about this, but it still boggles the mind just how much materials are on these objects. You know, a 500-meter, first of all, this room is probably, 50 yards by 40 yards, and of a typical platinum-rich asteroid of this size, you're talking about tens of billions of dollars of platinum group metals. And a typical water-rich, a carbonaceous asteroid of this size has on it millions and millions and millions of pounds of water that can be converted into rocket fuel or used for life support and breathable air, etc. So here's just a little bit of a description on some of the asteroids. You've probably heard of these classes. They're broken down by what their semi-major axis the range of their semi-major axis is and how far outside of the Earth's orbit they go, or how far into the just at the beginning of the main asteroid belt. But there are plenty of asteroids. There are literally more than we could ever use. Okay, and what about the value? So one thing, this is we call it the MasterCard analysis. At the very beginning, at the most basic sense, we have a big market for asteroid exploration today. There are asteroid-focused space and science missions that are functioning and operating right now. One of the big flybys one of the big events of NASA's scientific year, of course, was the flyby of Vesta, and we have lots of money, hundreds of millions of dollars per year globally, going into asteroid exploration for science right now. Now, as soon as we convert and begin to access those asteroids for resources, we now move into a multi-$100 billion industry. The resource industry on Earth is hundreds of billions of dollars per year. Hundreds. That's a totally different scale from things like tourism. It's a whole new world, literally. And then, of course, the MasterCard part, which is, what is it worth to protect the Earth and to have the capability as a human species to move and alter the trajectories and orbits of potentially harmful objects from space? And the answer is, of course, it's priceless. So on many levels, the ability, this is a classic case of opportunity and threat. And we have in these near-Earth objects, many of which could pose a threat to the Earth one day. In the other side of the mirror of that same object is yet one of our greatest opportunities as a spacefaring species. So it's really, really exciting. So just to give you an example, there are lots of different types of asteroids. We have the metallic ones, the stony ones, the carbonaceous ones, and different subcategories of each. Just to show you an example of one of the more interesting types, this is a carbonaceous asteroid. The carbonaceous ones are great because they have lots of different materials that are all good stuff. Okay? So they're mostly silicates, but inside them, many of them have very high platinum group metal content. And platinum, of course, is a very interesting element because, as you know, it's very high atomic number, it's very dense. The density of water, for example, is 1 gram per cubic centimeter, and the density of platinum is like 20 grams per cubic centimeter. So if you had a glass of water, imagine that being 20 times heavier just in the same amount of volume. It'd be extremely dense. So what happens in the early solar system is those really super dense iron-loving metals and elements get stuck right in the center of the planetary development system, and so you end up with nothing on the surface. And that's why the Earth doesn't actually have a lot of platinum group metals on its surface. Even the best mines are measured in parts per billion in terms of the platinum. And so the asteroids, if you find the right ones, are much, much higher concentration. And it's a real, by the way, the average cost of platinum group metals is thousands of dollars per ounce. So we're talking about an ability to go to these asteroids and find materials that are just not possible to find that much of them on Earth. All the platinum that has ever been mined in human history would easily fit on the stage I'm standing on, about 1 meter tall. It's amazing how little there is on the Earth. And by the way, it's also amazing how useful it is, from things like medical devices to catalytic converters, to microprocessors. It's got great conductive properties and all sorts of different things. I won't go into it, but there's a lot of value in these metals. And the other great thing about the carbonaceous chondrites is the fact that they have volatiles on them. They have ice, water ice. There's also much smaller amounts, but yet there is other forms of volatiles as well, for even things like methane. And most of you probably know methane has a better name, which is natural gas. It's a great hydrocarbon. It's a great rocket fuel. And so we can go to these carbonaceous asteroids and take the volatiles off them, use them for fuel, use them to create orbital propellant depots and deep space propellant depots that can drastically increase the amount of exploration that we can do beyond low Earth orbit for a fraction of the cost, while at the same time accessing these metals and these precious materials that we have such a hard time finding on Earth. So carbonaceous, just as an example, is a very, very valuable type of asteroid that certainly is high on the list. Talked about this a little bit, but again, we talk about the 500-meter type example. I told you what it would be like for a 50-meter one, but if you make it just a little bit bigger, so the size of 5 football fields, if you've got one that's high in water, so typical water content, you're talking about essentially $5 trillion worth of water if you had to pay current launch cost to launch it from the surface of the Earth. Even if you cut that down to 1% of that, 1% of 5 trillion is $50 billion. So it's an incredible amount of water. Water is the most important substance for human exploration of space, period. You need water for humans to live. You need water for humans to support life around them, to grow food and things like that. And of course, you need water to break into the propellant to let us travel freely throughout the solar system. And that same asteroid, or that same size of asteroid, the metal content, again, you're talking about far more platinum group metals than have ever been mined in human history, and in fact, exceeding the total known reserves of platinum group metals on the Earth. So these are super valuable diamonds in the rough, if you will, these asteroids. That's why we decided to start with the asteroids. This is a nice chart that talks about sort of the process of how and what the roadmap would be for using these. You can see from the beginning in the lower left-hand corner where we would launch our spacecraft, we have the series of spacecraft that we're going to use to explore is called the ARCID line of spacecraft. And so many ARCID spacecraft will be on one mission that will go to a single target. So there'll perhaps be a group of 7 or 10 that are all working together as a distributed spacecraft. And so as these spacecraft go to the asteroid and rendezvous with it and dock with it and dwell on it, and eventually asteroids are chosen for processing, those two components of material types will be treated separately, with the water used for fuel, and we would use something like high temperature electrolysis, which is a very highly concentrated heat transformation technique, which with something like 65% efficiency can break frozen ice into its constituent liquid oxygen and liquid hydrogen. Use that for propellant. And the nice thing about that is that once you've got that system going, your ability not only to move the asteroid, but to move the other materials around in space and to deliver those materials to the point of need is there. And you could almost say it's free as you generate that. It's as big of an energy generation device as you can build. If you have megawatts or tens of megawatts of power in space, you focus that wonderful 1.366 kilowatts per meter squared of solar energy that's with you 24 hours a day, 365 days a year, and you use that energy to create those fuel and those propellant depots, then you can do whatever you want with the rest of that stuff. And so that's why we show in here that you can use those resources to enable the roadways to Mars, to other asteroids, to the moon, or even to bring it back to Earth. And it's really a dependence upon where these materials are needed and what they're going to be used for. Okay, so how has this all become possible? Well, there's really a couple different constituencies of people. The first, when Peter Diamandis and I founded the company, was to really find some of the best technical people, in fact, the best technical people we could find to really carry the flag forward. And we started with none other than Chris, who I introduced before, Chris Lewicki, who spent the first half of his career, or at least the last decade of his life, working at JPL, working very closely as a mission manager and a technical lead on the last three spacecraft that have been to Mars. So lots of deep space experience, and he pulled together another dozen of the top engineers. We have people not only from NASA and not only from the aerospace industry, but very much like other companies that are really trying to radically improve the state of technology. We've brought people in from outside the space industry. One of our engineers, for example, was one of the top people on Intel's i5 chip line. And the ability to bring state-of-the-art processing power and state-of-the-art techniques in software and communications and all these other things is critical to driving the cost down and making these spacecraft, these prospectors that we have, as inexpensive as possible. So as we were building this team of guys and gals to go and do this, we obviously had to have the funding and really pull together a group of investors who would be patient and would be with us for the long run. And we've been very fortunate in that regard to have pulled together what I would consider to be, certainly one of the dream teams of space financing. I mean, these are people who have been very successful in industries, and in fact, not only starting companies, but starting those industries. Okay, my friend and business partner who's been to space twice, Charles Simoni, he was the guy who invented perhaps the most famous or useful productivity tool of all time, Microsoft Word and Excel, and was the guy behind all that. The gentleman from Google, Larry Page and Eric Schmidt, they started an industry. This goes well beyond search and internet. I mean, these people have changed the very face of our life in many ways, and they understand what it takes to do that and the patience it takes, and quite frankly, the money it takes. And so we've got a number of other very high net worth individual investors beyond just the ones you see here. Too many, frankly, to name, and some of whom wish to remain confidential. But it's a testament to the value of an idea whose time has come, that actually going out and finding investors for this company, while it was not easy, was just a lot easier than I've seen what it's been historically. And I think that we're ready. This is the 21st century. It's time for asteroid mining. It's time to bring those resources from space into our economic sphere, into really moving the needle for human spaceflight and beyond. So we're very fortunate to have these folks, and they're very committed. They've supported us not only with their pocketbook, but with their words, with their time, and very, very fortunate to have those folks. Just a reminder, I suppose, people, in the mainstream press, people in this room, not so much, because you would, of course, know this, but have wondered, wow, this seems so new. We don't know anything about these asteroids. How can you manage to even think about something like this? And the fact of the matter is that we do know a lot about asteroids. We've flown as a world many missions. We've returned small amounts of material back from asteroids. And so this is that next logical step. There are hundreds of millions of dollars per year being spent by space agencies, and we would love to be able to go to those space agencies years from now, maybe not that many years, but certainly in the future, and say, look, we can do 90% of what you would like to do for 1% of the cost. Because we're not building, and this is not a bash to NASA or any other space agency. I mean, these government space exploration efforts play an absolutely important role, and we would never have gotten there if we didn't have the government leading the way. But we would love to be able to apply commercial best practices and to really bring private investment in and being able to take the risks the government cannot take. Chris has a great quote that I'm going to take from, but I'll credit you with right now, which is, when failure is not an option, success becomes really damn expensive. And so you need to be able, when you have missions, to be able to take risks that may result in some failures that may not have your mission fail, but at least would be cost effective. Why would you pay, instead of, for example, that's why we have an architecture of using many small spacecraft instead of one big one. If you distribute the spacecraft, and if every spacecraft has a 5% failure rate, I'm making it up, okay? But we send 7 of them, and you only need 5 to have mission success, or 6. You're going to have mission success, because the integral of all those different spacecraft means that even if you lose one, you're still gonna be successful. So anyway, those are the kinds of things that we're doing out there. I guess I already started to segue into that in our approach. We are the main bullets are, we are bringing commercial innovation into what has traditionally been a very long time scale and sort of more government style approach. We are bringing up-to-date, state-of-the-art technology. If this phone right now has in it more processing power than 95% of the satellites that are in orbit right now, that's a travesty, okay? I want to be able to take my Arcid spacecraft, and if we've got a launch in 2 months, I want to be able to, and a new camera comes out, or a new processor, or a new app, whatever it is that we need, I want to be able to plug that in, take the old one out, and have it, cost us 5 hours of work. We can't do that, we can't do that because we've got this space-qualified processor that was built 15 years ago, and we have to use that one because it's the only one that's been qualified for space, okay? We have a clean room at our headquarters in Bellevue. One day I hope to get rid of the damn clean room. Why? Why don't we build things that can work where it's dusty and dirty and do all these things so that it's not an event. It shouldn't be an event every time one of these launches happens. We should be sending so many spacecraft out into the solar system to explore that it's not something that everybody in the world stands up and watches every time it happens. That's the kind of numbers we need to get to really make humanity a spacefaring species. Okay. So what are we doing different? What are we doing different? Well, aside from finding private investors to fund the whole thing and really trying to get the best people in the world from outside the aerospace industry to be part of it, we're moving towards vertically integrated development. Of course, if there is stuff available that's commercially available off the shelf, we're going to use that. We're going to make sure there's multiple suppliers. But if we need to make our own progress in certain technical areas, we're going to build this stuff ourselves. Okay, one example of that, and Chris can talk more about this, but optical communications. You know, the Voyager spacecraft, as you well know, it's out there, you know, however many billions of miles away from us. It's got that antenna that's the size, you know, it's 50 feet long. Why do you think that that whole thing was designed around the antenna? Okay, now obviously it's going out of the solar system, but the point is that spacecraft that use radio waves are inherently larger, bigger, and therefore more costly because you're using radio frequencies. Okay, and if we can get the antenna and the comm device down to optical wavelengths, you could ostensibly communicate with a deep space spacecraft using the same optics that you use for the analysis that the mission of the spacecraft itself. Laser communications, optical communications, a huge area, and if we nail the optical communications part of it, that's going to open up all kinds of opportunity in other industries and other areas. So that's one of the areas we're talking about. We also have propulsion. We have taking satellite components and systems that work in low Earth orbit where we're protected by the Van Allen belts and make sure that they work out in deeper space where there's much more radiation. So rad hardening of these components is another big area. We also have a different strategy. It's something that I've always felt was important, frankly, because I had to. In the early days of space adventures, it was so difficult to find investors that it was almost easier to find customers. And so we've set a goal for ourselves, in fact, a demand from the very beginning to be cash flow positive, to be profitable, so we can sustain our company, even though we have billionaire investors. We want to sustain our company forever. Okay, we don't want to be dependent upon NASA budgets or the ups and downs of the stock market, or whether whether people get fed up with risky ventures and there's recessions or Facebook stock crashes or whatever. This thing needs to be sustainable. It is going to be hard. There's going to be failures. There's going to be setbacks, and we need to make sure that this effort continues long beyond those ups and downs, which could kill a company that wasn't disciplined enough to make sure they were profitable from day one. And what does that mean? That means we're going to, even though we're doing very aggressive and risky things, it means we got to be careful. It means we're not going to hire 1,000 people right off the bat. It means we're going to make sure that we bite off pieces that we can chew and we can make our business happen and our business case close piece by piece. So a little bit of a roadmap. I talked about the ARCID series. The ARCID series is the group of spacecraft that are going to prospect the top several dozen near-Earth asteroids. We want to send these spacecraft in swarms to the top several dozen near-Earth asteroids. The ARCID 100 series will be tested out in low Earth orbit. The ARCID 200 series adds some of the components that enables us to go to deep space, and the ARCID 300 series combines it all with propulsion, comm, rad hardening, the ability to work in a distributed computing environment, really literally like a distributed computing environment. Think of it as a distributed spacecraft. Okay, so here, this is our big story that sort of takes you from how we get from one ARCID 100 series that we're going to fly 18 months from now. We're going to add to it and create a constellation of ARCID 100 series. So we test these systems out in low Earth orbit. It's the exact same bus that flies the 100, the 200, and the 300 series and beyond. We're going to make these things Fords, not Ferraris. We're trying to make them cheap. At scale, I want this 30 to 50 pound satellite to cost $250,000 or less. These things need to be printable off an assembly line. And as launch costs come down, we'll be sending these things out into the solar system like Imperial probe droids, okay? That's what we want, all right? And so that's how we're going to make it happen. And as you go down to the bottom right corner of this chart, you see that ultimately, of those 10,000 near-Earth asteroids, hopefully by the time we've got to that point, there'll be 50,000 near-Earth asteroids that we've discovered. But whatever those top 1% are, whichever those ones are that have the optimum of the materials you want, the locations that they're in, the energy difference, the periodicity that they have with the Earth or whatever target, the moon base, the Mars base, the asteroid human targets that we may have for NASA, the flexible path, whatever it is, we will prospect and then eventually finance the extraction and the development of all those top near-Earth targets. By the way, just as an example of the cool stuff that's come out since our announcement, there's a guy who got so excited about what we're doing, he wrote up his own website called asterank.com. And so I haven't analyzed it, and we've obviously done our own analysis on the kinds of targets that we think are the most valuable, but he basically downloaded the publicly available asteroid databases, matched it up to his algorithm for weighting their value in terms of current material values and their energy difference and all this kind of stuff, and has ranked the most valuable asteroids. And it's really cool, but we have our own systems for doing that, but just an example of the kind of passion that's out there. We didn't even know who this guy was. He later applied for a job, and we'll be talking to him, but really cool. So what is that vision for the future? It is all about the vision of the National Space Society. It is completely aligned with that. It's about settling space. It's about having that sustainable presence off of Earth, okay? Whether it's on Mars, whether it's on the moon, hopefully it's on all of them. Whether it's on the asteroids, whether it's a moon of Jupiter, who knows? But we have to use the resources of space in order to develop those settlements. We have to. By the way, I'd love to give a credit for this great image to Brian, who's over there in the corner, who's just done a great job with these asteroid imagery. Love it. And so one of the big questions that I get from groups all around who are big fans of space is, how do I get involved? What can you do? Well, there's actually a few things you can do. First of all, we are going to probably, differently than has been done before, we are going to open up some parts of our mission planning and maybe even some of our technology components to the community. Okay, so we haven't decided how we're going to do this yet, and I won't talk too much about it, but the whole concept of maybe open sourcing a little bit of part of this, or crowd working, we're going to have ways for the community to get involved. And so think about that and follow us and stay tuned for that, because for those of you who are out there, whether you're engineers or scientists or not, we'll find a way for you to get involved. Come to the website, register your name, follow us on Twitter, all that kind of stuff, and there'll be opportunities for the community to get involved. This is too important of an adventure, it's too important of a task not to involve as many people out there as we can in providing value to make this happen. And so you'll be able to do that. And that's really the main part of the presentation. I would love to, let's see here, in terms of time, we now have about 20 minutes, even to stay on schedule. So could we do some question and answer now, Paul?
Absolutely.
So Chris, why don't you come up with me, and we'll take the questions together.
So I normally take the MC's prerogative and ask the first question, but I know that all of you out there probably have a lot of questions, so I'm going to defer to you all. Let's take this gentleman right here in the blue shirt.
You had several figures as to how much profit you make from each asteroid. Do these account for the fact that the markets of these resources, at least back on Earth, will probably crash if you were to, say, capture an asteroid or start harvesting from its resources?
Yeah, the question was, do the models and estimates for the value of an asteroid account for the fact that flooding the market with materials would drop the price? And the answer is, our models certainly account for that. And that's a question I get asked all the time in the media, and my answer is, I want that problem. That's a great problem to have. A world of abundance is one where platinum can be used in every device that benefits humanity, whether it's artificial organs or processors that drive, medical devices or whatever it is, because it shouldn't be $1,500 an ounce to use the best material that it can. It's a world of abundance. Go read Peter Diamandis' book about abundance. It's dead on. We need to make these materials much more broadly available and less expensive.
Thank you.
Seth?
A couple of years ago, NASA was interested in fuel depots. In fact, I presented some of the work that a couple of ISDCs ago. Have you been speaking to either them or another anchor customer? Because it looks to me like what we do these studies and then they go off and are archived on the website and never hear from them again. It seems to me if we had some cheap water to put in it, it would be alive.
The short answer is yes. I think that fuel depots, propellant depots, strategically placed throughout the inner solar system is a key capability. And it's got a mass amplification, a payload delivery amplification factor. So no matter what the launch vehicle is, whether it's a Falcon 9 Heavy or an SLS or an Atlas or a Delta, whatever, you can always take more to where you're going in deep space if you've got a gas station out there. It's just common sense. So that's a huge part of our plan.
I'll make a comment about that as well. I'll just make one comment on behalf of the NSS. Yesterday we hosted a workshop, space technology workshop in conjunction with the Office of the Chief Technologist and industry and some other stakeholders from the Hill on specifically those topics. We were looking at solar electric propulsion and, more importantly, cryogenic propellant storage and transfer. And these are two things that are being funded through NASA right now. And probably the most important thing about that is that OCT is going out and pursuing these studies, but HEO, Human Exploration, it's the mission director that used to be operations, is interested in this. And they're saying we are waiting for when the risk reduction and the technology maturation happens to incorporate this into our architecture. So those things are actually starting to happen within NASA. Yes, sir.
Once you've identified a promising asteroid, do you envision mining it in its current orbit or modifying its orbit to bring it closer to Earth where the transportation costs are lower?
That's a great question. The answer is TBD. I think that we would have certain cases where we would leave the asteroid where it is and others where we might move it to a more favorable orbit.
Let's take one from over here, John.
Yeah. You mentioned the depots and you mentioned artists. Now, I've been promoting depots since 2005. And I think it's a critical issue. If you have a reusable spacecraft, you need a gas station for it. But it's very difficult to find a complete illustration of a depot with sun shields and multiple docking ports that illustrates what a real transfer station depot, say in L1 or 2, would look like. And you have obviously a very good artist and video producer. If we could get some of these things produced so that people could use them, giving your company credit for the art, to be able to show people how this fuel would actually be used to access the moon and Mars, it would be very, very valuable.
Yeah, great. Talk to Brian. He's the best. Back in the corner here. So, yep, right here.
For the characterization of candidate objects, from my knowledge of remote sensing of asteroids, many of them have very weak or almost invisible spectral features. It seems to me you need a specific variant of the Archive 100 that covers with a single channel spectrometer from the near infrared at 5 microns out to the near ultraviolet, and that you would just stare at objects as they fly past the Earth for 1 week to accumulate a very high signal-to-noise spectrum to identify just what type of object it is.
Sure. Yeah, so that our plan in terms of using our Orchid series of spacecraft is to not only do our own identification, but assist the big program that's already doing a lot of it that we're benefiting from today. And then what we'll do, when we can kind of make that first down select of the ones that look a little bit more interesting, we'll send those spacecraft in for a much closer look, including going all the way down to the surface, picking up a piece and going even deeper than that.
Hi, Eric. I heard you saying that the reason you're going after the asteroid for the resources because you think it's a low-hanging fruit. Because ever since I heard that a couple of weeks ago at the announcement of start of the company, my question I've always want to ask you, have you guys thought about harvesting energy from space, the energy of the sun, like a space solar power? Don't you think, have you compared or made an assessment, that's maybe a lower hanging fruit as compared to the going after the mining of the asteroids?
Yeah, the question was about space-based solar power, and certainly thought about that. I do think there is validity to that. I have my own ideas on how that might work. I think it could be useful to have a network that was deployable for where price wasn't an issue. But I don't think that's actually easier they're all difficult. I kind of want to imply that it's easy, but I think that the logical next step for this is to go after the asteroids that can provide propellant for propellant depots, fuel depots. Yeah. Over here.
Follow-up question and follow-up, sure. On space solar power, what do you think the implications are of successful asteroid mining for the potential of space solar power if the asteroid mining happened first? And turn it around, if space solar power happened first, this would have implications for how easy it would be to do asteroid mining.
Well, look, if we, for those who want to develop space solar power, asteroid mining would be incredibly beneficial because you wouldn't have to launch the materials that you can use to build them.
Yeah,
so,
not only the structural materials, but the semiconductors.
So, yeah. Question here.
Yes, I've asked this question early this morning, but I'm going to repeat it to you. President Obama set a goal of landing on an asteroid by the year 2025. Would this be useful to you or beneficial to you, or would it be relevant to you and your plans whatsoever? I mean, would it help you or would it have no effect on you? I mean, what would be the relationship? How would it benefit you? How would it affect you?
I'll assume what you mean is, would it be good for our company if there were human exploration to asteroids? Yes, I think that any human exploration, whether it's to the moon, the asteroids, or Mars, any commitment by national space agencies to send people into deep space is great for our company, but more importantly, it's great for humanity. And we would hope to be able to provide the fuel and materials along the way to allow those missions to be successful and less risky and lower cost. Back there in the, yep.
I'm in the wind and solar business here on Earth, and I would like you to speak a little bit about the importance of the rare earths that you can get out of the asteroids. With China trying to corner the market here on Earth with the rare earths that we need to make magnets and batteries. I think it's much more valuable to have the rare earths than actually the platinum that come out of an asteroid. And the second question is, how can we invest? Thank you.
What was the second question? Oh, how can you invest? Well, the rare earths are actually not, we don't know of the asteroid types that are rich in rare earth metals, to be quite honest. The platinum group metals are known. Iron is known. Cobalt, these kinds of nickel, these are known to be in the asteroids, as well as the volatiles and the carbonaceous chondrites. But the rare earth metals, unfortunately, we do not know whether there are asteroids that have those in great quantities. And as to whether you can invest, probably not right now, but there may be a time. You should register your name on the website. We have a place where you can do that for later. Right here.
So one of the most significant obstacles of having fuel depots is the significant boil-off rate. Has your company looked into the scope of how to prevent that, maybe like composite materials? Because we're talking about sustainability, we want whatever we harvest to be sustainable. So what is your view on that?
Yeah, there are ways to do that. I don't know if you want to take this.
Well, yeah. The way that fuel depots have been looked at for a long time is with the cryogenic storage of the fuels. And in many ways, the ice, that's the hydrogen and the oxygen that are those cryogens, have been out in the solar system for eons, and they haven't boiled off because they're in the form of ice and they're well insulated. So one option, and it depends on who's using and who's providing, is to store that material in the form of ice and transport it in the form of ice, and then when it's needed, produce the cryogens at the point when you're actually fueling up.
Yeah, there are also, I just spent the other day with the guy, Nathan Myhrvold from Intellectual Ventures, who was showing off this new thermos that they've developed that can literally, I mean, it radiates like 1 joule per year or something. It's a tiny amount of thermal losses through it, whether things stay hot or cold. And there's a lot of advancements in that kind of technology. I think we can cover those pretty well. Question here.
I'm a 10th grader in high school, and I want to study physics in college. What can you tell me about employment opportunities in 10 to 15 years?
I think that if you study physics and computers and science and technology, you'll be fine. And I hope that in 10 or 15 years, we will have 10 or 15,000 people working on mining 10 or 15 different asteroids that are providing $10 or $15 billion each, either to the space economy or back to the global economy.
We've got time for about
two more questions. Okay, let's do one right here.
If you're going to be searching for a lot of near-Earth asteroids, in addition to Planetary Resources, you're also going to be helping out with planetary defense. Are you doing anything active there right now, or is that kind of something, if you find something, you'll tell NATO about it? Or
Yes, well, certainly in information when discoveries are made or when follow-ups are made or more detailed orbits are determined, that's information that, of course, is useful to everyone, and that'll be shared. And this is a strong interest that we have, and folks on our advisory board like Tom Jones commit a lot of their time and attention to make sure that these things are prominent.
We're getting red lines installed in our offices, and so if we discover one like that, we immediately call NATO and tell them. NORAD. Okay, let's do one last question from all the way in the back. How about you, Chuck? I can see you from back here.
The fundamental question of ownership, claiming, all of those UN treaty type things, are you going to just take possession being 9/10 of the law, or are you thinking about drafting some legislation or going into COPUS and actively talking about this?
That's a great question, so I'm glad you asked that. We are, first of all, the Outer Space Treaty does not prevent asteroid mining. Okay, we believe, in fact, we're quite sure that the Outer Space Treaty allows for private companies to take resources from asteroids and use them. Okay? Having said that, there will undoubtedly be an evolving legal structure for this enterprise. We want that, okay? I think it's not too dissimilar from what happened back in 2004 when we had private citizens start to go to the space station and the X Prize was won, and all of a sudden we realized, hey, we better do something about this, and we came up with the Commercial Space Launch Act of 2004 and really moved the legislation forward there. I personally, and I've talked to some people who are in positions where they could make this happen. We personally, as a company, we would love to see a national U.S. law in the United States of America that is somewhat akin to a Homestead Act that says, we believe this is important. We want to lead the world in this endeavor. If you're a U.S. company and you're doing business in this country, we will protect your right to go to an asteroid and beneficiate it and do something with it, and you've got the mineral rights to it and you can own it. That's what this country should be doing.
Well, that's a great note to finish on, and thank you, Eric and Chris, both of you all, for your talk. And we are having an asteroid panel tomorrow afternoon, I believe, at 2 o'clock, and Chris will be on that panel. We'll be joined by some other asteroid aspects. So we'll be able to drill down into some of the details. But this has been fantastic. Yeah, no pun intended. Drill down into the details. This has been fantastic because how often is it that you have a commercial endeavor stand up and say exactly something that's in the vision of the National Space Society? So this has really been fantastic. And so, Eric, we'd like to present you with this small token of our appreciation. You can obviously see this is the near-Earth space with Mars, the Moon. I think there's an asteroid in there, and hopefully, as you say, we're bringing these objects back into our economic sphere of influence. So, thank you very much.
That's great. Thank you so much.
Take one picture here.
Thank you. It's really for Chris and I and the whole team, so I'll proudly represent us all here.
Great.
So
And,
thank you
and
very
just
much.
one last announcement to make to finish up on a positive note. As I said, and you can see from Eric's passion and energy that he's very much aligned with our goals. So as officially on Sunday, Eric will be the newest member of our Board of Governors. And so let's congratulate him on that. And so thank you very much. We're right on time. We'll see you in the parallel tracks. Thank you.
See the catch one? No.